Alright, today we're going to go over some forces notes. So what we're going to look for are what are forces and how do I identify them. If at any point during this video I'm going too fast, you can just stop, catch up on the notes, and then hit play to keep up. So the first thing we need to know, is there a force? So a force is present if you observe either a change in shape, called deformation, or a change in motion, an object speeding up, slowing down, or changing direction. Remember, this speeding up, slowing down, or changing direction is also called acceleration. Alright, so just remember, a change in shape or a change in motion. So where do forces come from? All forces can be traced back to four original or fundamental forces. We have gravity, electromagnetic, strong, and weak. Now you see on your foldables that there are 10 forces, and I didn't just list 10 forces, I listed 4. All of the forces listed on your foldable can fall into one of these 4 categories, but we have specific names for them in this class. So now I'm going to go over a little bit more about the 4 fundamental forces. We can order them in strength. Our strongest force is going to be called strong. Real shocker there, huh? And then we have electromagnetic, weak, and gravitational. Our weakest is gravitational. Now, you're going to see strong and weak forces only act over very small distances, about the size of a nucleus. Now, this strong force I'm talking about, we really don't see it that often. You're going to see it at like the atomic level when you can't break apart a proton and a neutron, kind of things. But we don't see that very often. Electromagnetic and gravitational act over large distances and are responsible for the macroscopic forces we observe each day. And we're going to go over those to a greater extent. Now we have 2 types of forces. We have field forces. And you see how all the field forces are listed on one side. That's because these forces act at a distance. They do not have to touch. Then we have our contact forces. And those are forces that act through contact. So these do have to touch. That's why they're listed on different sides, to help you guys clarify which ones do touch and which ones don't have to touch. Here's some examples, some pictures of our contact forces and our field forces. So you see an elastic compression for our contact, we see friction for our contact, and pull on our contact side. But then on our field forces side, you'll see gravity, magnetism, and electricity. Alright, so what I'm going to go over now is our 3 field forces. We're going to go over these in a little bit of depth. You're going to see these are on your left side of your force notes. Now when we go to each one, you're going to flip over the tab and take the notes under the tab. Alright, so the first thing you're going to do, flip your little tab over, and you're going to see that circle on the back of the yellow sheet. This is where you're going to write your symbol. So for gravitational force, our symbol is F and then sub G. This kind of looks like when we did our energy, how you wrote a big E and then you wrote your smaller ones, but this time we're writing an F for force. So gravitational force is F little g. The definition of gravitational force is an attraction between 2 objects that have a mass. So if you think about it, every object has mass. So it's pretty much the attraction between 2 objects anytime. An example of gravitational force would be a ball falling. So the ball is being pulled towards the earth. The 2 objects in this situation are the ball and earth. However, earth is such a big mass that it's not going to be pulled towards the ball. It's going to have such a big mass that the ball is going to come towards the earth because the ball is smaller or less mass. Another example you're going to see is sitting. If you're sitting, you are being pulled down towards the earth. And the earth is being kind of pulled on you, but again, the mass issue. You see in this example how, yes, you are touching, so even though it's a field force, you can touch in this situation, but you don't have to touch, because if I were to jump up in the air, gravity still wouldn't go away. If gravity suddenly went away, I would float up from my chair. Another example of gravitational force is planets rotating around the sun. They're pulled toward the sun. Yes, technically the sun is pulled toward us, but again, the sun is way bigger and the earth is smaller than the sun. So you're going to see the earth being pulled toward the sun, but then we make a rotational path. Now, another example you might think is the moon, because the moon rotates around the earth. The moon is being pulled toward the earth. However, with the earth situation, we do see evidence of the moon's gravity working on earth. We see that in the tides on earth. So when the tide rise and the tide fall, that is the evidence that gravity is being affected. The force of gravity is here on earth and on the moon. All right, so evidence. This is what you're going to write not on the flap. You need to write this on your notebook page. Based on our lab stations we went through, what evidence did you see in the stations that there is gravitational force acting on an object? So you might have seen this in the Jake Brown video clip where the skateboarder went up and then he came back down. You might have heard the saying before, what goes up must come down. That's the gravitational force. All right, electromagnetic force. This is the big middle flap. This one is F, big F, little em. You're going to write this in the circle again. It might look more like an oval on this one, but you're going to write it in the oval. The definition of this is repulsion and attraction caused by charged particles and charged fields. Now, we don't really see this one that much, but it's pretty clear when you do. It's electromagnetic, electricity, magnetism. Some examples of this: voltage in a battery, lightning/static shock. We're going to see this when we do a Van de Graaff generator. Magnets, yeah, electromagnetic magnets. And then you're going to see magnetic materials like a compass. So the compass works because of an electromagnetic force. So what evidence did you see in the stations that there was an electromagnetic force acting on the object? This is going to go on your notebook part, not the flap part. Here, you just remember what stations you did. And if you need to come in, come see us to do stations. Last but not least is nuclear force. This is done by big F, little NUC. You're going to write this on the back of your nuclear force one, in the circle this time. So nuclear force is interactions inside and between the nuclei of atoms. Some examples of this, as I said earlier, your strong and weak force, that really strong force that keeps an atom together. You're also going to see this at nuclear power plants, a nuclear bomb, the sun. Deep in the core of the sun, it undergoes fusion, which is an example of a nuclear force. And then you're going to see this in nuclear medicine, which is made in nuclear reactors. So those are our three field forces: gravitational, electromagnetic, and nuclear. Again, I just want to emphasize, these are called field forces, so it is not necessary for them to touch. However, in the situation of gravitational force, I can be sitting down and gravity is still there because I don't start floating up. But if I were to jump up in the air suddenly, the gravitational force is there to make sure I come down.